On the coordinate plane, a horizontal line runs parallel to the x-axis. The blue line shown on the graph is an example of a horizontal line. If we examine the points of this line more closely, we notice that they all share the same y-coordinate. For example, this line intersects the y-axis at the point 0, 4. It also passes through the point 5, 4, and the point -3, 4, as well as many other points, all having that same y-coordinate of 4. By contrast, a vertical line on the coordinate plane runs parallel to the y-axis. The red line shown on the graph is an example of a vertical line. All the points on a vertical line have the same x-coordinate. For example, we can see this vertical line intersects the x-axis at 3, 0, and it also passes through points like 3, 2, and 3, -4. So we can see that all the points on this vertical line have the same x-coordinate of 3. We can draw graphs of horizontal and vertical lines by generating a table of ordered pairs, just as we have done for graphing other linear equations. As an example, let's graph the line y equals 2. Notice that this equation does not contain the variable x, which means that regardless of the numbers that are chosen for x, the y-coordinate of each ordered pair is unaffected. For example, if we choose x equals 0, in order for the equation y equals 2 to be true, the y-coordinate must be 2. Or if we choose x equals 1, again, in order for the equation to be true, y must be 2. We could choose x equals -3, and again, for the equation to be true, y equals 2. So we see that those 3 points, when plotted on the coordinate plane, as 0, 2, 1, 2, and -3, 2, all form a horizontal line. This is what we would expect since they all share the same y-coordinate. Let's look at another example and graph the equation x equals -3. In this case, the equation does not contain the variable y. This means that regardless of which number is chosen for y, the x value of every ordered pair must be -3. If y equals 0, in order for the equation to be true, x equals -3. If y equals 1, x equals -3. If y equals -2, x equals -3. Plotting those 3 points on the coordinate plane, -3, 0, -3, 1, and -3, -2, we see that they form a vertical line. And this is again what we would expect since all of these points have the same x-coordinate. Once we've seen the relationship between the equations of horizontal and vertical lines and their graphs, we can actually graph these equations much more quickly without making a table. For example, number 1, let's graph the equation y equals -4. We know that every y-coordinate must be equal to -4, so this is a horizontal line, and it must pass through -4 on the y-axis. What about equation number 2, x equals 5? We know that the x-coordinate of every point on this line must be 5. So this is a vertical line that passes through 5 on the x-axis. It's also possible to work in reverse. Given the graph of a horizontal or vertical line, we can easily determine the equation for that graph. In example number 1, we see a horizontal line passing through 1 on the y-axis. So its equation is y equals 1. In example 2, we see a vertical line passing through -2 on the x-axis. So its equation is x equals -2.